one good thing where we learn to listen to our customers, to understand our customers, to offer our customers what they really need, right? Understanding the pain point. This develops the technology further and further by means of opportunities.
On this episode of Embedded Insiders, Dr. Konstantin Klopschek, CTO at Digid, joins the podcast to explain the benefits and breakthroughs his company's been able to achieve with nanoscale sensing. We discuss the miniaturization of sensors in real-world environments, reliability and durability concerns, and collaborations. Later, Rich and Altera's president and CEO, Rahib Hussain, discuss where the company's been and where it's going. They dive into Altera's offerings, roadmap, and the relationships they've made along the way. Hello, everyone, and welcome back to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, joined with our Editor-in-Chief, Ken Briota. How are you, Ken?
I'm fine, Tiara. How are you today?
I'm good. Enjoying the short work week.
Yeah, I mean, I wish I was enjoying it. I am very busy getting ready to go to Computex next week in Taiwan, but that's not bad. That's just a lot.
Yeah, that you've got a lot of travel ahead of you, so.
Absolutely. So I'm excited about everything that's coming up, but that's not what we're going to talk about today. I heard you had a really cool interview.
Yes, and I won't get too deep into it. It's pretty technical. But at Embedded World, I got the opportunity to meet with a company called Digid and followed up with them, and we did a podcast, and that's what you'll be listening to next. But we mostly discussed topics of nanosensing and miniaturization, especially when it comes to sensors. Obviously, sensors are everywhere. They're being, applied to robotics and medical devices and even in industrial automation solutions. So we talked about just their ability to scale sensors so small, and what was once seen as more of research-based and prototypes, but Digit has actually achieved like manufacturable products for deployment. And we kind of just went through that, but I kind of just wanted to talk about the fact that everything is shrinking so small. Like, I guess in this case, it's not necessarily the product itself, it's the sensors, but everything has a sensor, everything needs to fit such a small sensor or, something like that. But I just thought it was interesting. What do you think?
I think it's really, really cool. Obviously, the more granular you can get with your sensing, the more you can know about the environment, and presumably the sooner you can know about a problem, which, that's not all that sensing does, but anomaly detection and identification of problems early is really, really powerful stuff. If you've got just in a really clumsy example, a gas leak somewhere, the sooner you can detect those particles of methane or whatever, the sooner you can solve the problem, the more likely it is you can keep people safe. The sooner you know about an electrical short, the more likely it is you can prevent downtime and end up not having to stop the line or not for as long. It's really, really cool how all, as you said, all the way down to the molecular scale, they're able to do detecting, and obviously not just for chemicals, but temperature and a few other things.
Hmm.
It's really, really cool stuff and worth taking a look at. I hope folks really enjoy the interview because it's good stuff.
Yeah, and I'll leave it to Constantine, who'll be on the podcast speaking about it. But one of my, I guess, favorite things about meeting them at Embedded World was how hands-on their booth felt. they had so many different types of sensors displayed, and things that you could touch. And I remember there was like almost like a paper film like sensor that he placed on my hand, and just seeing all that in person is quite crazy. So um yeah, that was just one of the meetings that I had at Embedded World that really stuck with me. And I even got to take a small sensor home. So yeah, I just think it's really interesting. I think it's something that I don't get to hear a ton about. I mean, obviously we hear about sensors a lot, but um, not quite to the scale of what Digit is doing. So I just wanted to give them the platform to share their their insight.
Yeah. Yeah, I look forward. I haven't heard the interview yet myself. I look forward to listening to it and finding out more about these guys. I think that I'm working on an article right now on some of the uh, advancements that's been going on with sensors and sensor fusion and that kind of thing. And this is exactly the kind of technology I've been looking into. So I'm really excited to listen to the interview, and I know the folks out there who are listening will be too.
Yep. Stay tuned for the next interview and stay tuned for Ken's article.
Have a great one, everybody.
Now here's Konstantin Klopstek of Digit.
So my name is Dr. Konstantin Klopstech. I'm a physicist by profession, did my PhD in physics, and I'm working as the one of two general managers at Digit as the CTO, caring about the technical developments of the company.
How would you explain nanoscale sensing to someone who's familiar with more traditional sensors, but new to this level of miniaturization?
Yeah, good question. So it all boils down to provide a proper sense of scale. And this is what we transmit with the needle video, where we zoom on one additively manufactured sensor sitting on a hypodermic needle, right? Just to bring people in a sense of scale. Normally, if we don't have the video at our fingertips, we explain to our customers that we have likely the smallest sensor in the world, and by scale, the next biggest sensor would be 4 orders of magnitude bigger than what we have, right? So, but this is not easily to comprehend. So this is why we normally show the video, and in order to engage people with what nanoscale technology means. If we have customers that have a more mechanical background that want to try to embed our sensor technology. If your product has a scratch or a tolerance, right? A metal tolerance is normally on a micrometer scale. We will definitely be able to fit our sensors as we're even smaller than a highly precise metallic working tolerance that's established. So it's all bringing people into a perspective of what small things mean, right?
Mhm. So, in your opinion, what are the biggest challenges when adopting nanoscale sensors in real-world industrial environments or any environment?
Yeah, good question again. So I think the thing that we have established that cost the most resources was to bring this in a manufacturable scale, right? So it doesn't, it's not enough if you have a sensor available that works in a laboratory scale. If you can do it in the tens of units, right? You need to bring it into the hundreds, thousands, the millions of units that you can fabricate in order to provide it. This is the one thing. And with the fabrication, we will always say our process is fully industrialized. What does it mean? We have a quality control established so that we know how the quality of the output sensors are, right? This is in particular cumbersome to achieve as the sensors are so small, right? So it's not that you can go there and gauge if everything is okay. You need to come up with smart new quality control measures that we have, and we have patented this as well, for example. So we know what we fabricate. And then the next thing is now you have a sensor, you can produce it at scale, but how do you bring it in your customers' products? And this is the next big part that we needed to achieve is the sensor is the true innovation, but anything else, the readout, the electrical contacting, the encapsulation of the sensor, for example, this is where we are working with standard processes already established in the industries, right? So, for example, the thin film electrodes that we are providing are provided by either suppliers that we have or by custom. Sorry, I need to charge by custom processes that we can offer ourselves. And this is the thing most people forget. If you have an innovation, it's nice. And if you have the IP for the innovation, nice as well. But bringing this in the real world, right? Thinking this through with the customer, applying a process chain that's not just robust and working, right? But also scalable and cost effective. This is the next biggest step to having this process at your fingertips for bringing this into the real world, so to say.
And I think you answered my next question just a little bit, but I kind of want to know how is Digit's approach to nanoscale sensing different from more conventional sensing technologies?
Yeah.
How are you guys? Yeah.
Yes, so I think what we can offer to our customers is we can measure what's called in situ. Our sensors are so small they don't interfere with given thermals, for example. It's so small we can measure what we call where it matters. Right? If you want to have a temperature, for example, on a chip, we can bring the sensor directly on the chip or at the chip or in future potentially in the chip. And it's not that you would use a traditional sensor far away from the temperature you want to measure. It's that you can bring our technology right where it should be measured, either temperature or forces. So think of the scaffold blade. This is the one video we always show. It's just a product demonstration where we take something that already exists. It's a scaffold blade, right? And we can enhance it. We can make it better. We can make it force sensitive without interfering with the original use case. So it still behaves like a blade, feels like a blade. So it's not that you need to sacrifice usability or expertise in usability, for example, in order to employ our sensor technology. This is why we call ourselves malleable, right? We will adjust our technology to your traditional use cases, not that we want to change your product in any particular way. Is that we always try to provide you with a sensor technology that works, that gives you the insight. For example, with thermal monitoring, we call this deep thermal insight because we not just measure a temperature, but we can deduce the source temperature a little bit away from our sensor technology, or we can give you precise force readings where you want to have it. Right? I think sometimes we get the feedback that engineers can now follow their gut feeling. For example, we had the customer that says, okay, as an engineer, I want to introduce the force sensors right there, but they wouldn't fit. And we said, no, they will fit. And then he said, yeah, it's easily solved then. And we said, yeah, this is what we offer. We offer new ease of applying our technology where you want them to be, where you wish them to be, right? And it's not the issue anymore with big sensors, for example. Miniaturization, this is a big thing where we are working in, and this is what a lot of companies want to strive in. So we can achieve this miniaturization with respect to conventional sensing that hits somewhat a level of miniaturization that you can't enhance in any reason, right?
So you mentioned the importance of usability. How do you support reliability and durability when working with sensors at the nanoscale, sensors that are so small and potentially fragile?
Yeah, right. So this is the one big misconception. People always think of something small must be super fragile, right? But think, for example, of optical fibers. It's glass, but you can bend them, they won't break, right? Because black glass at small scales behaves completely different. This is called the flexible rigidity, which goes down if you miniaturize things. For example, having thinner glass makes it flexible, makes it bendable. And our sensors, they cannot fly in thin air, right? They need what's called a substrate, a force transducer, or a thermal piece of technology that you want to monitor thermally, for example. And our sensors live on these substrates, right? So the rigidity of the substrate defines the rigidity of the sensor. We tested our sensors to 10 to the power of 13 bending cycles, for example. This is mechanical testing. This is what's going on. We tested them for high strain levels, so you can stretch them by 60 to 80%, and they still survive this, right? Even though, for example, gold electrodes would yield to such stretches. This is hidden in the sensor materials properties and also in being so small. And we heated the sensors up to high temperatures like 200, 250 degrees centigrade, even 400 degrees centigrade. And the sensors, they are impacted by these high temperatures, but they survive it, right? We say for a temperature sensor, it lives between minus 250 and plus 250 degrees. And again, this shows how robust and rigid the technology in itself is, right? So even though the sensor is small, it's not brittle. And for example, we can measure forces down to the piconewton, nanonewton range. And with the same sensor on a different substrate, we can measure kilonewtons, right? And you may ask, okay, how is this feasible? It's the same sensor on a different substrate. For such small forces, you would use the MEMS substrate, which is a microelectronic mechanical system. And for high forces, you would use a rigid metallic substrate, for example, right? So this is how we can always guarantee our customers that they will get a solid sensor. One particular thing is that we can encapsulate our sensors with a multitude of standard processes found in the industry, for example, polymers, for example, thin layers, in order to prevent sensors from being attacked from corrosive acids or I don't know what crazily high UV radiations or radiation in general, right? So we can encapsulate our sensors for multitude of opportunities in the industry. For example, protect them from grease, from wear and tear, right? So it's not that the sensor in itself must feature rigidity. It's again the whole environment that must be rigid.
Mm-hmm. Can you talk more about maybe how simulation addresses challenges with these sensors before physical deployment, maybe with your collaboration with ANSYS?
Yeah, right. So yeah, we are lucky that we started a collaboration with ANSYS for finite element simulation, which is the market leader in the industries, right? And it gives us the ease of being able to simulate mechanical loads and thermal loads on the sensor, right? So, for example, if you have a piece of metal and you want to detect a certain amount of force that acts on the metal, we know precisely where to put on the sensor, right? And the beauty is that we have what we call a validated finite element model, where we know that the outcome of the simulation is in really good accordance with the later tested sensor performance, right? So ANSYS, it's the industry standard, not for no reason, right? So they know what to do. We are trained in using ANSYS, and this gives us the benefit that we know the outcome of the sensor performance even before we establish the sensor on materials. So this works for ceramics, this works for metals, for polymers. It's a completely different story because of non-linearities, right? This is where we would need to tweak the model in itself. For example, if you have the sensor on a polyimide, you want to stretch it to high levels, you would need to tweak the simulation with real measured data of the mechanical parameters of the polyimide. But in general, we stick to what we call linear materials. And then we have one beauty because our sensor is intrinsically high sensitive, right? It has a really high gauge factor, much higher than foil strain gauges, for example. We can go down to what is called in physics the small signal approximation, where you are basically in a linear regime. And this makes then the whole simulation much more easier, right? The linear regime means double the amount of force, we get double the amount of stress on the sensor, so double the amount of sensor signal. And this is where we try to position our sensors in order to have a rigid setup. And again, it's not like, for example, people use the simulation in research, for example. We just want to understand of how to implement the sensor for best signal, right? But also with respect to manufacturing. There might be a good position where the signal is really strong, but it might not be accessible during manufacturing, right? So it's not just a tool for deducing electronic signal levels, it's also a tool for starting the implementation process, right? For example, customers approach us and ask for sensor implementation, and we provide them for free what we call a concept. So this is basically the idea of where to put the sensor. And ANSYS is like a sparring partner in the thinking process. Normally, for example, you don't have a good gut feeling when it comes to small scales, nonlinear materials, or complex geometrical configuration of substrate, right? You don't have the feeling from what you saw before, where to put the sensor in an ideal way. And we can skip all the gut feeling stuff, right? We can be precise by simulating the substrates, mechanical response, for example, or even thermal response with ANSYS. And then we don't need to think. We can look where to put the sensors because normally there's a multitude of good spots where to put the sensor. And then with respect to your first question, and being so small has the beauty so that you can really independently decide where to put the sensor. We always try to make a good spot of where is the sensor working the best, where it's protected the best, for example, so you can ease your process load and money that needs to be spent in the sensor protection, for example. So with ANSYS, it's not just the sensor thing, it's the complete implementation process that we can have a rough look on. So again, the devil is hidden in the details. You need to put a lot of effort in the next steps of the implementation, for example. But ANSYS, think of a map where we see the sensor would be situated in northwest better than in southeast, for example, right? And from there on, we can sketch a concept for our customers.
Awesome. So looking toward the future, as this technology matures, how do you see industries and applications being transformed by nanoscale sensing?
Yeah, so this is a multitude of opportunities here. So I think biggest interest, this is what we get from our customers, is in miniaturization, right? Companies wants to make technology disappear, right? You want to provide, for example, in consumer products, you want to have an ease of use. For example, our novel human-machine interface based on force sensors and temperature sensors, right, makes it easier to sense human inputs, for example, in earbuds that are even smaller than the buds today, right? And again, miniaturization, combination of sensors. What we see is people ask us, for example, for a combination of a force and a temperature sensor in the same spot, not just for human machine interfaces, but also for pressure sensors, for example, where we have a small MEMS. This is, I think, where we can bring worlds together that were before our technology far apart because of build space, because of technologies that won't fit to one another, right? And I think having the sensors disappear, right? At the moment, you have your system set up on the one hand side, and you have your sensors concept on the other side, and you need to merge both worlds, right? And it's always the case that you need to sacrifice some requirements either on the sensor side or on the system side in order to make things work. And this is where our biggest USP is with our technology, the sacrification is as small as possible because the sensor is so small. And from there on, you get highly integrated systems with a combination of sensors, right? This is the one part in final products that you can sell. But on the other hand, the companies approach us that need interference-free readings in a precise manner of forces or temperature in order to develop their next generation of products, right? So they want to have a feedback during product development, but they don't have sensors that can deduce the proper measurements they want to have access to, right? Think of a big temperature sensor that changes the surface temperature while being employed, and our sensor wouldn't change the temperature as much, right? So you would get a much more precise reading, and I think this is the next good opportunity for our company, where we would be in some years ahead, that our sensor technology is used for product development as well. So not just in products, it's also used for product development. And then again, we are learning every week and every day with every customer inquiry, new aspects of our technology, right? If I would tell you what I understand the benefit of being small to be, next week, I can guarantee you a customer will call us and I would have a new point in why being small is a big advantage, right? So we are still evaluating the capabilities of our technology. We learn with each and every customer. And I think this is a really good spot to be in, because the integration pathways of the sensors starts to be a burden, because it's a completely different story in medical product than in aerospace, than in digital silicon, than in high power silicon materials, for example, right? And this is where we build up a strong expertise over the last 18 months, for example, with our customer base, so that we sort of converge more and more into standard application for our sensors in a different variety of products or application bases. But we're learning with every day, and every week we get a nice new setup of sensor applications that are inquired by our customers. And I think this is the beauty. You have a machine that can do a multitude of nice pieces or parts, right? But we inspire the customers. This is, for example, why we sit down with you guys or other news outlets in order to inspire generations of engineers, right? Because they have the issues, right? By no means we will ever be an expert in all the fields. It's not feasible, right? This is one good thing where we learn to listen to our customers, to understand our customers, to offer our customers what they really need, right? Understanding the pain point. This develops the technology further and further by means of opportunities. And we spoke about technology. So again, I think the most prominent part is to understand that the sensor is innovation, and the utilization of the sensor relies on standard technologies, right? Technologies, for example, our customers already have, right? We would never sell them an electronic readout if they're an electronic readout company that already has such a device, right? We will always try to adjust our technology to what the customer already has at hand.
Now, here's Rich and Altera's Rahib Hussain.
Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. We have a special guest this week, the CEO of Altera, Rahib Hussain. How you doing, Rahib?
I'm doing great, Rich. It's my pleasure to be with you today.
Awesome. Well, I know how busy you are, and I do appreciate you carving out a few minutes for me. So let's get right down to it. Let's see, how do I phrase this the right way? Altera's been in and out, you know, in embedded, out of embedded. They've been with Intel and out of Intel. I was on record years ago when Altera was first part of Intel as saying, this could be the best thing. If they do this right, this is going to be fantastic and they'll dominate the world. And it didn't happen. And it was very disappointing that it didn't happen. So I know a bunch of things have happened along the way with private equity and all that, but I don't care about that. Our readers are technical people who are your customers, your potential customers. They want to know what you're going to do for them today. So let's get to why is now the right time for Altera? Why should somebody who's either a customer or a potential customer hop onto that train?
Yeah, so that's a very good question. So I'll start with this fact that once again, Altera is operating as a pure play FPGA solution provider with a single focus, and that is to bring programmable logic innovation to solve customer problem, right? Now, there are lots of good things happen, and of course during Intel thing. So one of the greatest things from the customer point of view, Intel helped keeping the leadership of the fabric. Fabric is the key for FPGA, and we still have the best fabric, in terms of Fmax frequency as well as utilization that you can achieve in the overall logic. So that's the best part. Now, of course, there was some certain market segment prioritization under Intel. So, for example, wireless and data center, and today we have a very strong position in those markets. But then with the independence, we actually have a full freedom to bring the full portfolio across the broader market, because this is all FPGA is about, for a broader portfolio end to end. That's what we are committed to. So I think that's a good news for our customer and all the FPGA users out there.
So what are the application spaces that you really want to go after that you'll say Altera will dominate in these spaces?
So as I said, we want to be the leader in FPGA FPGA-based solution provider, right? So we already have a very strong position in data center and wireless, but we want to go in across all the industries, the embedded, the test and measure to industrial and aerospace and all those application and security and so on. But what is unique right now is which I think is going to drive the overall TAM of the FPGA is the relevance of FPGA in the physical AI, right? So this is where the AI overall data center AI as well as physical AI, FPGAs are playing a critical role to be I would say the companion to the inference and the overall GPU, and that is where I think that a lot of growth is coming. So yes, we would like to be the leader in the broader FPGA application, but with a special focus on the AI.
Why is Rahib Hussain the guy to lead Altera?
Well, so that's a very good question. I have been in semiconductor for about 30 years, and I was co-founder of Cavium, and then from there Marvell acquired Cavium, and I was president of Marvell and help being part of the leading the transformation of Marvell. In my opinion, what is needed for Altera, when it's coming out of Intel, is to bring the focus back. And when I talk about focus, it's really the customer first mindset. It's a mindset that our purpose of existence is to solve customer problem, and anything and everything we do is for that purpose. So we drive innovation, we drive excellence in execution, we drive quality, we drive fast decision making, but that is all working closely with the customer to solve their problem, right? And that's how I have built all my businesses throughout my life, and that's the culture I am bringing here in Altera. And I think that is a key to achieve the success together with a customer.
You've said a few times that the goal is to solve the customer's problems, and obviously that's what's important here. It could be taken as a throwaway line. How do you know what the customer's problems are?
So that is a very, very interesting question, because as I said, the best way is to go work closely with the customer, try to understand what is their goal, what are their challenges, and what problem they are trying to solve. And that is more of a style and mindset of the company, which sometimes people call it engineer first mindset, versus, hey, I have built this product which I believe is great and is a great portfolio, and thou shall use it. That's not my style. My style is this: hey, we are focused to solve your problem. We are agile. Nothing is written in stone. Of course, we have our roadmap and we are driving those things. But when it comes to the details of those, how, what, and how, this is where the close partnership with customer helps. This is where you go with your larger set of customers and try to spend time, try to not just listen to them, but really understand their problem, their challenges, and their goals. Because if you understand that, then you can help them win, and if they win, ultimately you win. So right, so that's a mindset and culture, and that's more of an engineering first, driving creativity and innovation first mindset, and that's what I think is the culture that we are driving here.
To that end, how involved do you get with your customer's customer?
So based on the markets, many times we do get involved with because so you have to have full awareness of the ecosystem. You can't just say, hey, this is a part I'm selling to this particular box, and that's all it matters. You need to understand what is the end goal, where the end market is going, how things are evolving, and what needs is it driving to our customers' equipment, which actually in the end will drive for us. So those are the things you have to understand. So for example, I'll give you a simple example. Let's say the right now memory market is in kind of trouble, sort of a thing. It's hard to find memories, and especially DDR4 is kind of end of lifing, right? So having, if you were working with your customer closely, and this thing, you can figure it out, which Altera did actually, that hey, DDR5 is important. So we did implement DDR5 in our product portfolio, for example, which is being very helpful for our customer right now. So that is just one example. There can be many such examples, especially in this time when we are going through its transition, where everything needs to improve the performance efficiency driven by use of AI. So this is where a lot of use cases are evolving, and having the understanding of end use cases is what helps you to bring the best solution for your customer.
So are you required to be more agile than you would have expected because of this memory issue, for example? But there's other reasons. Like another one is that AI is far more important. I don't know if important is the right word, but involved in everything that we do every day than most of us would have expected. So is the agility that's required, is it more difficult than you thought it would be?
Not really, because as I told you, that's how my style has been throughout. So in my mind, yes, we do. In any company, I worked with, hey, this is my 3-year, 5-year roadmap, right? However, you can't. That is not written in stone, right? Because the thing is, you have to keep steering as the market is changing, and in right now in this time, market is changing very fast, right? So if you do not align yourself with the needs of your customer and end market and end application, you will become irrelevant, right? So that is where you have to, while you are executing this year roadmap, because you have to do it, because you can just keep changing your immediate thing. But how do you steer, and how do you keep doing course correction is also equally applicable. In my opinion, however, FPGA are the best fit for that, because by definition, FPGAs are very agile and very flexible, right? So many of the things in FPGA you can actually adapt much more easier compared to, let's say, custom silicon. I mean, I'm coming from that background. There, when you say, hey, this is what I'm building, that is hard to make big changes. But in FPGA, a lot of aspect of the design can keep evolving even after deployment. As long as you have the right building block and right hooks.
Excellent. So you've been in this position for about a year now. What's the thing you're most proud of that's happened over the course of the last 12 months?
So I would say, first of all, I'm really proud of the mindset change that I have brought here. So I have brought this winning mindset and yes, we can attitude, right? So I think that to me is important. You should always start the conversation, yes, we can, and then figure out what are the natural and physical and other resource related limitation, and that kind of forces you to think out of the box also a little bit. It's not like, okay, this is my group, or this is I'm talking about at a function level, this is how I am, how many resources I have, and this is all we can do, right? It kind of opens up your mind and say, hey, what is the possibility, what is the excellence, level of excellence in the world, and are we there or not? And if we are not there, why are we not there? What can we do to get there? So that kind of, I would say, the mindset culture is very important. The second thing is more like a sports team culture, where we all work together, but we all kind of push each other to achieve the next level of excellence, right? I can see that that is happening a lot. I'm really proud of my leadership team that I have built. We are all with the same mindset, and with the same style, that achieving the end goal, which is actually making our customers successful, right? So that's how we live by. So when you have that mindset and you have that passion to achieve that customer success, it's a completely different style, completely different kind of type of a company. Second is thing, of course, that immediately brings to achieve that, we have to improve our overall execution excellence, the quality of the product, and actually improving the overall portfolio. So I'm really pleased with in how much have we improve in all those things in how little of a time, right? And everybody is stepping up and carrying not only their own weight but also helping others get to the next level. So I would say it's a completely different company. It's I call many time in customer meeting, I say, hey, think of us as a startup but with a very large base, right?
Very good.
because the hunger, the passion and the drive and the focus that we have and the agility, which is like a startup, but at the same time, we are an established company and with a large business.
Excellent. Okay, so last one for you. If we're having this conversation 2 years from now, what is it that we're talking about? What's dominating your life, your engineers' lives? What are the problems that you need to solve for your customers?
So this is very interesting question because I keep thinking about it. At the pace the world is changing, in fact, anything you predict in the even next 6 months is probably going to be different. It's probably going to be changed. All the things that we have experienced in the last 1 year. I mean, if you go back and say, would you have had thought about it? Like, it's really difficult. So in these circumstances, what matter is you keep very close alignment with the customer, keep that engagement and keep monitoring the end goals, right? So that's what we'll keep in. But one thing I can, based on our plan, what I can predict is, one thing is, in 2 years we will have a very strong complete portfolio. We will have our trust rebuilt to the very high level that I am trying to drive internally. The customer trust on us that we do deliver what we say we will deliver. We deliver on time, we deliver with the quality. So all those things I am driving to achieve in that time frame. And that's the third thing is this: we will be a very strong player when it comes to AI, both on the infrastructure side, solving as a companion chip to the other processors, or in the physical AI side as well, where we are really solving the problems of the physical interface of the world with the AI, where I believe the FPGA is most relevant solution.
Awesome. Thank you very much, Rahib. This is great.
Yep. Thank you for your time, and I really enjoyed our conversation, and I look forward to having more of these.
Thank you very much. That was Rahib Hussain. He is the CEO of Altera, and I am Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.